And so we can use this knowledge and we can look at the other planets in our solar system and check out their magnetic fields and see why or why not they might have one. So we can start with Mercury. Mercury has an incredibly weak magnetic field, barely there, probably because it has such a slow rotation. It's just not spinning fast enough to get this dynamo mechanism operating to kind of crank up a magnetic field. It's still rotating a little bit, so it gets a little bit of a magnetic field. Venus also has a slow rotation, but the problem with Venus especially is that it has uniform heat throughout the core. There's no heat difference. It does have a hot core, but the surface is also very, very hot, right? And the reason the surface is very, very hot for two reasons. One, it has this nice, thick atmosphere, this thick security blanket over the planet Venus that traps a lot of heat. It keeps the surface incredibly hot. And there are no plate tectonics going on. Plate tectonics play a role in the Earth. Since they dredge up material from deeper in the Earth and put them on the surface, this is a way of bringing up heat. You got hot stuff and you're going to pull it up to the top and it's going to cool off and then it'll sink back down. It's a way of pulling heat out of that core. Since Venus doesn't have that, or a lot of plate tectonics, and has this thick atmosphere, the interior of the planet Venus is pretty much uniform temperature. It's not like the Earth where it's super hot inside and pretty cold on the outside edge. Pretty uniform. No heat difference, no conduction, no magnetic field. Sorry, Venus, you're out of the game. Mars, we think, used to have a magnetic field, but Mars is small. Mars is a lot smaller than the Earth. It cooled off a long time ago. It doesn't have a liquid layer in its core anymore. It's just all solid. No more conduction. No more magnetic field. Sorry. So we think it used to like billions of years ago, and then it let it go. And because it lost its magnetic field, it lost its protection against the solar wind, and it lost its atmosphere. Jupiter, nice big fat gas giant, has a lot of what's called liquid metallic hydrogen, which is a super cool topic, which I need to devote an entire show to. So please, someone ask me about liquid metallic hydrogen and I'll dig into that more. And it has really rapid rotation. So you know what? Jupiter, king of the planets, king of the magnetic fields. Way to go, Jupiter. Saturn, same thing. Not as strong because it's not as big. Still has a strong magnetic field. Uranus and Neptune aren't big enough to have that liquid metallic hydrogen stuff going on, but there are a lot of ions, a lot of charged particles, spinning really fast, a lot of convection of heat, boom, magnetic field. So really, it looks like gas giants, easy magnetic field, no problem. I mean, they don't even sweat and they get a magnetic field. Rocky planets, a little bit tricky. You have to be just right, and the Earth stands out. The Earth has a very strong field for our size. Remember, Venus, which is almost exactly like the Earth, has zero magnetic field.